Welcome to 240M. I am your instructor, Robert McMillen, and let's go over the Module 1 lecture, talk about our objectives. Our objectives for this module are going to be the network operating system, Windows Server 2012 editions, virtualization, troubleshooting tools, installation, and domain versus workgroup. Also, there'll be TCP/IP, static and dynamic addressing, IP4 and 6 addressing, name resolution, and TCP/IP tools. What is a network operating system? Well, this is an operating system designed to allow shared file and printer access among computers in a network. It includes an implementation of the TCP/IP protocol stack, and it implements security via user accounts, passwords, rights, and permissions. So what this means is you have a server and it becomes a domain controller, and then you have clients, which are your Windows host computers. Those computers connect to the server. The server will hand out resources such as file access, folder access, printer access, application access, and it will allow you to gain access to those different resources by username and passwords and setting up security. There are several different Windows Server 2012 editions. We have Server Foundation for small offices with one physical processor, although it can have as many cores as you'd like. There is the Server Essentials, which is for the next size up. It includes 2 physical processors, and you can put additional users above 15. Then there's Server Standard, which is what you will be using. It includes all the different domain services included in the 2008 Enterprise version, but they no longer have the Enterprise version, so you now get that in the standard one. And this is good for up to hundreds and hundreds of people connecting to this particular type of operating system. And then if you have thousands of people connecting, you'll want to go with the Server Data Center version. It is for critical business operations for many people, as well as cloud services. Let's talk about virtualization. Virtualization allows multiple guest operating systems to run concurrently on one computer and provides separate apps and services to client computers. This is what you will be doing in the 240M class. Hyper-V is Microsoft's native virtualization tool. You will not be using Hyper-V, you'll be using VirtualBox. But you will be installing VirtualBox on your host computer. This allows you to put VirtualBox onto a Macintosh, a Windows 7, a Windows XP, Windows 8, doesn't matter. You'll be able to use VirtualBox on any of those operating systems. Hyper-V, unfortunately, would not let you do that. How many virtual machines can you put on a computer? Well, it depends on how much RAM and processor and hard drive capacity your server or computer has. Memory can be allocated per virtual machine, as well as processors, and as well as hard drive space. What are the advantages to virtualization? Well, you have lower overall hardware costs, more efficient use of computer hardware, and physical space saving. So what this means to you is that if you're in a business considering installing multiple servers, then you may want to consider using virtualization because you don't need as many physical servers. Therefore, it's lower cost and doesn't use as much electricity or air conditioning, which also lowers your cost. The disadvantage is a single point of failure. What that means is that you have multiple operating systems all running on one physical box. If that physical box goes down, then all your operating systems are gone with it. So what a lot of businesses will do is they will have 2 boxes or more connected to a back-end storage device that allows for redundancy. So if the servers go down on one, they can be automatically moved to the other. Windows Diagnostic Infrastructure, extensive diagnostic and problem resolution architecture that offers improved diagnostic guidance, additional error reporting details, and expanded logging and extensive recovery policies. This Windows Diagnostic Infrastructure is a suite of programs that allows you to detect a lot of different problems and automatically fix those problems. And when it can't automatically fix the problems, it allows you to manually fix those problems. But it does give you a clue as to what's possibly wrong. One of those tools is the Startup Repair tool. if you have an operating system, a virtual operating system or physical, doesn't matter, and it will not boot into Windows, then you can use the Startup Repair tool, which automatically launches to try to fix the problem. You can boot off of your Windows DVD, or you can use the repair tool, which is the same tool, on the hard drive. It just depends on how badly damaged the hard drive is. So the Startup Repair tool will check for updates, see if there's an update that will fix the problem. It can also do a system disk test, sort of like a check disk. It can look at disk failure diagnostics, it can do a metadata test, or it can also look at the operating system software itself. So it can look at both hardware and software. There are 3 different installation methods. We will be doing the interactive setup, which is the default. What that means is when you put your DVD in or you boot off of your ISO file in VirtualBox, then it will ask you a series of questions. It will walk you through the setup process one step at a time until you answer all the questions, and then it will complete the installation. Some of those questions are, what would you like to name your computer? What domain or workgroup are you in? That kind of thing. The unattended answer file does the same thing as the interactive, but you preload all of the questions and answers into a file. There is an answer file executable that allows you to do this on the DVD, and it will automatically answer all those questions for you. And then the last version is the unattended with Windows Deployment Services. This allows you to do the same as the unattended, but it also allows you to do it to workstations, and you can do it remotely as well. 2 different types of licensing, per server and per user. When you purchase your operating system, you need to find out how many servers you're going to need and how many users will connect to those servers, and buy a client access license, or a CAL, for each one of them. There are 2 different types of requirements as far as being able to install Windows 2012. First are the minimum requirements, and the second are the recommended requirements. Minimum requirements are the requirements from Microsoft that say you cannot install Windows 2012 unless you have at least a certain amount of RAM, processor speed, or hard drive space. Recommended requirements are requirements by Microsoft that says if you use these recommended requirements or something greater, then it will not only install like the minimum, but it will also run at optimal speed. Clean versus upgrade. When you are doing your installation, you will be prompted with an option to either upgrade your operating system or do a clean installation. We will choose the clean install or custom option, and that's because this is a blank hard drive. You can also do that on a server that has an operating system on it, and you can create a dual boot situation if you would like to do that. Upgrade is if you have a 2008 version, you'd like to upgrade to 2012, where it keeps all of your basic configurations as far as users, applications, and security, and we'll just upgrade that up to 2012. You will also be prompted during installation for either a full server or server core installation. The full server is the graphical user interface version that shows you what you are used to as far as the various different start menus and all the different ways that you would use a mouse to configure your server. The server core, on the other hand, is command line only, so it uses much less RAM. The minimum requirements are much less as well. It uses less hard drive, less CPU. And you would want to do this on an older server, or if you really want to put as many different virtual machines onto a server as possible. When you name your computer, we're going to name ours DC01, 02, and IT008. But when you name a computer outside of this class, you'll want to remember to keep the naming simple and functional and meaningful, such as if it's an email server, call it mail. Don't name it after a person or after a character in a movie, because then you really don't know if that person is going to leave the company. If you're going to need to rename it to be something else, that could cause problems. Also, if you name it after a movie character, you don't really know what that server does. Is it an email server, a domain controller, that kind of thing. And it also needs to be unique. Remember, you cannot have more than one device with the exact same name. So what is a protocol? A protocol is a language, and a language needs to be understood. So in this particular case, your computer also speaks a language, and when your computer wants to connect to the server, it by default will use TCP/IP. This is also the same protocol we use to connect to the internet. And then when you use TCP/IP, you can either create a static IP address or allow an automatic IP address to happen using a DHCP server, Dynamic Host Control Protocol. So let's take a quick look here at our server and see if we can find what we're looking for. So let's click on the control panel. And from here, we're going to go to the network and sharing center. And then we'll click on change adapter settings. Now we'll right click on our adapter, go to properties, and we're going to assign an IP address using TCP/IP version 4. So this is the IP address that should be on DCO1 192.168.0.1 with the subnet mask 255.3x0. We do not need a default gateway because your virtual machines will not access the internet. And then the preferred DNS server is showing the loopback address 127.0.0.1. That's fine. That loops back to 192.168.0.1. So you can either put this address in to the DNS on DCO1 or just the 127 address. Now on DCO2 and IT008, you want to put in 192.168.0.1 in your preferred DNS server, so it points back to DCO1. Domain membership versus workgroup. A domain is one or more computers or servers. Network administrators use servers to control the security and permissions for all computers on the domain. If you have a user account on the domain, you can log on to any computer. So what does that mean to you? Well, if you have 100 computers and you have multiple servers and your computer at your desk goes bad, you cannot log into it anymore because, say, a hard drive failure happens, you can go walk over to another computer that no one's using, log on with the exact same username and password, and the server will authenticate you, and you'll be able to gain the same access as if you were accessing your own computer. However, in a workgroup situation, that's not the case. The workgroup, you have to have a username and password on every single computer and every single server. It has very poor security and it's very difficult to manage. This is why we recommend you go with a domain rather than a workgroup when you have a business. TCP/IP is actually more than one protocol. It's a suite of protocols. TCP is the connection-oriented protocol, and what that does is it makes sure that when your computer connects to the server that there is a connection between the two and that it is not broken. IP, on the other hand, has the data itself and the routing information. So if you were to open up a Microsoft Word document and save it, and when to transmit it to the server, that would be in the IP, or the payload portion of the packet. So the IP header routes it from computer A to server B, and it also contains the document itself. On the other hand, UDP over IP is another protocol that can be used. It's not something we use with domain membership because it is connectionless, and we want to make sure that our connections are connection-oriented. Static addressing, as I showed you earlier, that's where you manually assign an IP address. And dynamic is if you have a DHCP server that automatically assigns the IP addresses. A couple of different types of TCP/IP that we talked about earlier is version 4 and version 6. So in your list of protocols, here's 6 and here's 4. We're not going to assign 6, although we are going to be going to that in the future. It won't be in this class. We'll just be using version 4. So a version 4 address has just 4 different what's called octets, and that's 2 to the 8th power at each octet. You add that all together and you have 2 to the 32nd power. Now if you had a calculator and you said, hey, what's 2 to the 32nd power? It would tell you 4.2 billion. Well, now that the internet is so popular, 4.2 billion is not enough internet addresses. So we are moving in the near future, some internet providers have already done this, to IP version 6. Now IP4 is a subset of 6, so you can move back and forth between the two with a translator that all the ISPs currently use. So how many addresses is a 128-bit TCP/IP version 6? Well, it allows you to have 80 trillion IP addresses for every user on the planet. There is a network ID and a host ID on an IP address. The left side of the IP address is the network, the right side is the host. So if we look at our example, without getting too complicated, 192.168.0 is our network. That means if you want to communicate with the server, you also have to be on 192.168.0. So DC02, it starts with 192.168.0 as well as IT008. Now on the host side, where you see a number 1, every one of those numbers has to be different from each other. You cannot have the same address on a street, for example. So you have to have a number 1 on DC01, a number 2 on DC02, a number 3 on IT008 for our labs to work properly. There are different classes of networks. There's Class A, Class B, Class C. Class A is any numbers that start from 1 through 127. It's designed when you need a large number of hosts but not a lot of networks. So if you have 100,000 people, for instance, in an office, but you have them all on the same subnet or a few subnets, then Class A would be a great way to go. Class B starts with numbers 128 through 191, and that's for medium-sized businesses that need, say, it has 65,000 hosts and 65,000 networks. That seems excessive, but there are some organizations that need that kind of thing. And Class C is the default that we're using, where we start with 192.168.0. Well, that's 192 makes it a Class C network. Private versus public. A private address on Class A, B, and C is going to see, as you see here, so anything that starts with a 10 means it's private. Anything that's a 172.16 through 172.31, that's private, as well as anything that starts with a 192.168. So what that means is, on the inside of your home or business, it's going to start with one of these three because they are not routed out to the internet. They are hidden behind your firewall. So anything that doesn't start with 192.168, 172, or 10 is a public address and can be used on the internet. It is routable. Hosts shouldn't be connected directly to the internet. So your 192.168.0 is not connected directly to the internet. It's hidden behind a firewall that does something called network address translation. This is a device router or gateway or firewall that's responsible for translating your public address to your private. So that way, you know when you go out to the internet that your real address is hidden from the rest of the world. It makes it less likely that you're going to be hacked. Subnet and subnet masks. So we talked about network. Network is another name for a subnet. In this particular case, you use a subnet mask to hide, not to hide, but to show how much of your IP address is your subnet. So in this particular case, 192.168.0, you see 255.255.255. That means anything to the left of this is network or subnet. Anything to the right is host, or your computer's a host, your smartphone's a host, your tablets are hosts. So if we were to change this to 255.255.0.0, that would mean that 192.168 is the network or subnet, and 0.1 is the host. So that means I could have a 192.168.1.1 communicate with a 192.168.0.1 because they would still technically be on the same subnet if I were to remove this 255 and replace it with a 0. So the left side is the subnet or the network, and the right side is the host. What are the minimum requirements to be on the internet? Well, you need an IP address. We need a subnet mask, which I showed you those two. You need a gateway, and our gateway we left blank on DC01 because that will not connect to the internet. And then we need DNS. So if you were to pull up a command prompt and type ipconfig/all, you would see all of those things in your network. So we see that our IP address is 192.168.15.2. That's our IP. Our subnet mask is the 3255.0. Our gateway, that's our way out to the internet, is 15.1. We have a DNS server, 75s all the way across, and we have a backup one as well. So this computer can access the internet. Name resolution. Well, how do we resolve names to IPs? If we were to go to CNN.com, how would it know how to get there? Well, it uses a DNS server in this particular case, domain name service. In the older computers, we used WINS with the Windows Internet Naming Service. It's not as popular as it once was. And then if you have a small network, you could use Link Local Multicast Name Resolution, so LLMNR. And these are different ways basically to resolve names to IP addresses. And this is how we find different, because computers go by IP address, we go by names because names are easier to remember. So you need a translation to be able to do that. And DNS and these other two are that way to do it. DNS is a database that enables computer names to be resolved to their corresponding IP addresses. They include host names and a domain name. It's in a tree-like structure. So Microsoft.com, for instance, the top level part of that, .com, is the top level domain name. The secondary level is Microsoft. So Microsoft.com, you're making widget LLC.internal. Widget LLC is your second level domain. .internal is your top level domain. Then you have the name of your computer, DCO1. If you put that all together, you have what's called a fully qualified domain name, or an FQDN. So if we type NSLOOKUP, and we can see that NSLOOKUP is going to show us that the default server is unknown. We did what's called a name server lookup. Now if we hit exit and we do an ipconfig/all, we can see that our fully qualified domain name is dco1.widgetllc.internal. So if we go into the DNS manager, you can see why it is that it works the way it does. So we'll double click on DNS. Our forward lookup, widgetllc.internal, is DCO1. Double click on that, and you see the fully qualified domain name, dco1.widgetllc.internal, and there's the IP address. This is called a host record. Reverse lookup has not been created. We're not doing reverse lookup in this particular class, but a reverse lookup does the other direction. If you ping the IP address, it shows up with the name, and that's the way NSLOOKUP actually works. Okay, we talked about the tree-like structure with the .edu, .com, .internal, that kind of thing, and the fully qualified domain name. We also talked about WINS. It uses NetBIOS to broadcast names, which is why it's not that efficient. It does not handle IP version 6, so it's not going to take us into the future. LLMNR is a peer-to-peer host naming resolution when we don't have a domain-like structure. It's just a peer-to-peer, like a workgroup situation. All right, there's additional tools. We looked at ipconfig, and we did not yet look at ping or traceroute. So if we were to look at ping, let's go ahead and ping DCO1. When we ping, it comes back with an IP version 6 and says it does work. If we do a ping DCO1 space -4, then it shows us the TCP/IP version 4 address. Traceroute's a little different. We do trace RT, and then we do a whatever it is that we're trying to go. So let's just go ahead and go to one of our domain DNS servers. And what it'll do is it will go out to the internet, and every single hop it takes from point A to point B is it's going to show us all the different locations it takes, as well as the name resolution of each of those. So we're getting a transmit error code on the virtual machine because we don't have a default gateway. But on our host computer, we can run that same command, and we can see that we do get out to the internet. So what it's doing now is it's showing 7 milliseconds and 10 millisecond response, and then it's showing each of the different hops it's taking to get to our destination, and it's resolving the names of these different ones if it has a name. For instance, this is going through Troutdale in Oregon, and it's using the Comcast network. So if it doesn't have a name, it just shows the IP address. Sometimes you'll see a star here, which means it's timing out. And that's okay, because eventually it will get to where we want it to go. If all you see is timeouts, then that means it never actually got to the internet. But in our particular case, we know this computer can get out to the internet, so eventually it will finish, and we'll be able to see that destination and how many hops it took to get there. Path ping is another command. We rarely use that one. Netstat is a command that shows us how many TCP active ports are open, and that can tell us whether or not our computer is vulnerable to any kind of attack and if we need to adjust our firewall. NSLOOKUP is the reverse lookup we talked about earlier. It looks up the domain name and then points it back to the server itself that we've set up. So in conclusion, we talked about our network operating system, Windows Server 2012 editions, virtualization, OS troubleshooting tools, installation, domain versus workgroup, TCP/IP, static and dynamic addressing, IP4 and 6 addressing, name resolution, and TCP/IP tools and commands.